Yes, thank you.
Welcome back. We are going to start that one. Here.
Yes, sir. I've gone through all
Yeah.
my
So
part.
after going through, you have any queries for the notes?
Yes, I have one big query.
Big. How big?
Uh, Small but very important.
Okay, small but very important. So which one? Which
Sir,
page?
it's the page 5, Newton's third law of motion.
Okay, okay. So yes, tell me.
Sir, is it always like compulsory that the forces will be like towards each other, like shown on the diagram, or can it be like facing away from each other?
Um, Look, what you asked, that is a very important question, and the answer is both. Answer is both. It can be like this, or it can be the other one you told. Hmm. So,
So, sir,
what is the
uh,
difference of first law and third law? There is one similarity and there is one difference. That one you have to understand first. The similarity is uh, in first law and third law, both we have balanced force.
hmm,
Okay, we have balanced force, but in first law, we have the forces working in the same object.
hmm,
We have the forces working on the same object. Like there is one object or one person on which two forces or more than two forces are working together, but the resultant force is zero.
hmm,
Okay, so that's why it is balanced force. But in Newton's third law, we have two forces and we have also two objects. Okay, we
hmm,
have two forces and we have also two objects. That is the difference. Okay, so
hmm.
in Newton's third law, the forces we are getting action and reaction, that is also called pair force, because
Hmm.
forces always occur in pairs. Forces always occur in pairs here, action and reaction force, and uh, there will be two objects or two persons or two bodies. Clear?
Hmm. Yes, sir.
Okay, now what you said, that here we got uh, two forces, working on each other this way. It can be like different, like they are all working also in opposite direction. That could be also happen in some cases. We will get some examples when we'll do the worksheet or we'll go more further. Then we'll understand it. Okay.
Yes, sir. I was talking about that in MCQ question number 8. They wanted to know which one's the
So
Newton's third
you
pair of.
you relate my that idea. If there is only one object and multiple forces working on it, that is first law. Okay.
Hmm.
And if it is if there are two objects working, uh, and there is pair force working, then it is third law. And if there is any resultant force, uh, available there, that is unbalanced force, right? uh, you see Newton's second law. So that if you think of unbalanced force, it is only Newton's second law. There will be resultant force. There will be acceleration. Okay,
Hmm.
and the
Excellent.
resultant force, direction, and acceleration direction will be the same. Okay,
Hmm.
acceleration will be in the same direction of the resultant force.
Okay.
You see here, Newton's second law of motion says that the resultant force acting on a body produces a net acceleration and causes the body to accelerate in the direction of the resultant force.
Hmm.
Okay,
Hmm.
now I think you will not face any problem. I already clarified the things where the students get confused about the balanced and unbalanced force at least. Okay,
Hmm.
then
Then
your big query is gone.
yes, my big query is done.
Okay. Now here you have
Friction
any
is easy.
confusion about the thinking distance, that, that one you are clear? Thinking distance, then stopping distance, braking distance. Are this clear?
Hmm.
You can see the screen, right?
Yes.
So are this clear? Stopping distance.
Yes, sir. I wanted to know a bit about centripetal force.
Okay, centripetal force is coming later. That one. Another thing I am sharing with you, that is frictional force always work uh, against the motion. Okay,
Hmm.
the direction of frictional force will be always opposite to the motion of the object. That one you remember.
Hmm.
Okay,
Hmm.
and this idea will help us to understand some of the questions. Now, this one I am just giving you little bit. Have a look here. And this one is thinking distance, right? This
Hmm.
thinking distance comes from thinking time or reaction time. We need some time to think and take decision, right? Before
Yes.
applying the brake, that one is already the car is moving. That's why when we are thinking to make a plan to stop the car, already we are going some distance, right?
Hmm.
That is called thinking distance. So this thinking distance is always, normally it is fixed unless and until the driver is sick or the driver is, distracted by something like he is talking over phone or anything else. That time, the thinking distance will be more, right? Otherwise, our reaction time is always constant. Human being, right?
Hmm. Hmm.
Then applying after applying brakes, it goes for deceleration, that is braking distance. Okay,
Hmm.
both thinking distance and braking distance are altogether called stopping distance. Okay, so braking distance increases if the road surface is slippery and the tire is not working properly, the brake is not working properly, if they are old, damaged, right?
More
Clear?
mass of the vehicle.
Clear to you this one?
Yes. Yes.
Okay, so if it is clear, then we will go to that one, circular motion. That is centripetal force, circular motion. You see, here we have circular motion. Circular motion can be in planets. Circular motion you can also make in your house, like you are taking one string and you are um, you are fixing one stone at the end of the string, then in your finger you are trying to make a circle by moving the stone right in the string.
Hmm.
That is called circular motion, right? if
Hmm.
if at any moment uh, you just leave the string for a while, then you will see the place you are leaving it uh, towards that place. Like here you are leaving the string, then the stone will go this direction, right?
Hmm.
So always the velocity or the speed will work in a direction of tangent with the circle, right?
Hmm. Hmm.
This way, if you throw here or if you leave the stone here, then it will go through this direction. You see some others are shown. So we never tell it velocity, uh, and only for an instant it is velocity, but for the whole thing it's no more velocity because it's always changing the direction, right? It's always changing
Hmm.
the direction. That's why we are saying it is speed, right? The
Yes.
velocity is always changing. That's why it is speed, right?
Hmm.
Now, uh, here we have force working. Because of this circular motion, there is one uh, force working towards the center of the circle. As for every moment, there is, your finger, the one you have contact with the string, uh, towards that direction, you will feel force working, right?
Hmm.
That is the action and reaction force. If you think that one force is working towards your finger, then your finger is giving another force opposite to it, right? So there is one force working towards the center of the circle, that is called centripetal force. And as there is centripetal force, according to Newton's second law, we have here centripetal acceleration also. Newton's second law said there will be acceleration towards the direction of the resultant force, right?
Hmm.
Hello,
Yes,
hello.
sir.
So there will
Yes,
be
sir.
uh, one acceleration also will work towards the center of circle.
Hmm.
Clear to you?
Yes, sir. So, sir, the centripetal force and the acceleration
They both,
and the resultant force, these three are all same towards the
yeah,
center.
the resultant force and centripetal force is same thing.
Hmm.
Sometimes you are saying resultant force, sometimes you are saying centripetal force. And
Okay. Okay.
according to second law, Newton's second law, as the direction of the force, resultant force is working towards the center of the circle, the acceleration will also work towards the center of the circle.
Okay. Exactly. Hmm.
Clear now?
Hmm. Hmm.
Okay, here we gave some examples. One example already I told you, that is the planetary movements, right? The Earth and
Hmm.
around the Sun, that movement is also a centripetal force. Okay, centripetal or circular motion. Clear to you? Electrons orbiting the nucleus, that one. Then a car is turning through a circular path, right? That one.
Hmm.
All this are circular motion. So
Yes, sir.
anything else?
One more.
Yeah.
Sir, the body at rest. I think it's in page 7.
Loudly, please.
Body at rest, page 7.
Page 7. Page 7. Hmm. Which one?
Body at rest. Sir, can you just summarize it?
Which one? Which one?
Body at rest. Yeah, the first part
Okay,
above
body at
the
rest. Okay, it's like there will be, resultant force is zero here, right? Body at rest because the weight and uh, there will be no, if the body is in rest, then there will be uh, actually
no resultant force
the
working.
way we understand the friction that when the object is moving, then with the surface there is one, friction, right? That time we
Hmm.
are getting frictional force. But if the body is at rest, uh, for that one, normally what happens, there will be one contact force working upwards and the weight is working downwards, right? Then
Hmm.
there will be balance, right? Resultant force is balanced. Okay,
Okay.
this way it works. So here, body at rest, you know that the like this one, this body, if it is uh, pulled with a force 4 Newton. Here they gave one example that you are uh, pulling one object. It is an exceptional case, right? Normally, what happens? The static object, you are sitting somewhere. What example I gave you about the contact force and weight, that is happening. But this one is an exceptional example. Like this object is pulled, right,
Hmm.
forward, and the frictional force is working here. So its pulling force is not enough. Its pulling force not enough to make a resultant force. Okay,
Hmm.
like when it's pulling with 4 Newton, it's also facing a resistive force or frictional force of 4 Newton.
Hmm.
Okay, with its surface.
Hmm.
That's why this forward force and backward force both are equal and opposite, right? They are balanced.
Yes.
If they are balanced, that means their resultant force is zero, so they will be in rest. As it was before in rest, it will be in rest. Okay,
Hmm.
it was not in motion.
Hmm.
Clear now?
Yes. Okay. Okay.
Okay, now if you pull it with 5 Newton force, then it will move. Why? It has some resultant force then, because frictional force is 4 Newton. It is fixed, right? For this object on this surface, the frictional force is fixed now, right? Uh,
Right.
so if you increase this pulling force, forward force, then you will get a resultant force of 1 Newton, right?
Yes.
So if you get one resultant force, then the object will move forward with that much acceleration. You have to calculate with the mass F equals ma. Then you will understand how much is the speed, how much is the acceleration.
Okay, sir.
Okay?
Sir, one more thing.
Yeah, sure.
Sir, like if somehow the like this block is being pulled with 5 Newton, for example, and friction is 4 Newton. So if somehow the friction of between the block and the surface decreases like to 2 Newton, so the object will move faster, right?
Yes, of course, of course. Like if you are giving oil here, or you are making the surface more smooth somehow, you are giving like in carom board. When you are
Hmm.
playing carom board, then you are giving some powder, right?
Hmm.
That time to make it more slippery, so that the things are going faster, right?
Sir, yes, yes, yes.
That like that one.
Okay. So, yes, sir. I think so. Uh, I think so all of my problems are finished.
Okay, if you are done with your all problems, then we are going to this worksheet, right?
Yes.
This one you tried, right?
Yes, sir. I tried, but since I did not have the notes that time, so I couldn't do much.
Okay, uh, now which one you are facing most problem? The MCQ part to get decision. Can you tell me?
Yes, it was question number 8.
It was question. So you are seeing the worksheet now, right? Worksheet
Yes.
on topic 3. Question number 8.
Hmm.
Question number 8. Oh, I'm going to page number 8. Question number 8. Yeah. Question number 8. Yeah, this one. This one. Yeah. This one now you can get. I think after getting the idea of first law and third law clearly, now you can understand it.
So it's
Third law pairs.
oh, so isn't the answer A?
Yes.
Oh,
Yes. There are two objects. One is a table and another one is book. That's why that's the answer, right?
but sir, in the C, there is also two. One is the electron and one is the nucleus.
Hmm? And C,
Sir, in
right?
yes, there are two things: nucleus and
Okay,
electron.
okay, okay. You got a correct point. Here you see, uh, yeah, yeah. Here they showed the table, but it's not the weight of the table, right? But they are showing the weight of the book, right?
Hmm.
And the normal contact force is also working on the book, right?
Hmm.
That's why uh, it will be, related to first law. You see,
Hmm.
but see, electron attracted to nucleus and nucleus attracted to electron. So here two things, right?
Hmm.
Hello, two things.
Yes,
One
sir.
is one is nucleus, another one is electron. So I think this one is will be appropriate, more appropriate. Again, uh, the other things. Check with this one. D. Here also one object, right? Two forces,
Hmm.
right? Hello.
Yes, but yes, sir.
So C will be correct answer. Most
Hmm.
appropriate for third law pairs.
Okay.
Yeah. Then
So, sir, can you just seize the answer because there are two
two
things.
objects. Two objects.
Yes,
Two
and
objects. Two forces.
both of them are opposite each other.
Hmm.
Okay, okay. Yeah, another one. Uh, yes, sir. I did till question number 9.
You did till question number 9, right?
Yes, I gave up then
Okay.
because
Okay.
I not
Okay.
have.
Now I think 9 you can try, right? On which car is there a resultant force?
Yes, it's B.
there is resultant force. What about A?
Sir, it's written constant speed,
Yeah,
so
it's
no
straight
acceleration.
horizontal road. That's why we cannot accept it. But there is bend, right? Here is
Hmm.
also constant speed, but it's bend, right? So there is circular motion.
Hmm.
In circular motion, there will be a resultant force, right, towards the center of the
Yes.
circle. Even if it's moving with constant speed. And why we are saying it constant speed?
Because there is no acceleration.
Because
Because there is no acceleration.
because there is acceleration because it's changing the
Oh,
direction.
oh yeah, yeah, because there is acceleration.
The
Yes.
velocity is changing the direction.
Hmm.
And
Sir, I was.
one thing I need to add with the other ideas I discussed, that is this is you know very exceptional idea about circular motion, that uh, because of the changing the direction of velocity, we are getting the acceleration. In in linear motion, what happens in linear motion, we are getting change in velocity, right? That is increasing the velocity or decreasing the velocity, right? And that's why we
Hmm.
are getting the acceleration. Okay.
Hmm.
But in circular motion, we are getting uh, the change of direction of velocity, right?
Change of
we are
direction of
we are
velocity.
not getting the change in magnitude of the velocity, but we are getting change in direction of velocity, right?
Hmm.
And because of this change in direction of velocity, there will be some acceleration. Okay.
Hmm.
And for this reason, we are getting resultant force towards the center of the sun.
Okay. Sir,
Have
what
you?
about C? I thought there will be. It's moving uphill, so it has to overcome some of the forces. I mean, the friction and weight.
You see, for this one also, our car moving uphill at constant velocity, that one also we are considering as a linear motion. It's not circular motion.
Hmm. Hmm.
Clear to you?
Yes,
Here
yes.
we have here constant velocity, and if it is linear motion, that is going through a straight horizontal road, that
Hmm.
is also giving us what?
Uh,
Balance force. If it
oh
is
yes.
constant velocity, right? Balance force or resultant force is zero. So that uh, in that case, we don't have any resultant force.
Hmm.
Maybe there will be working, weight. There will be working friction, and there will be working the what can we say, the forward force from the car, right? Three forces are working.
Hmm.
Okay, in the
Yes.
we are talking about C. So if all these forces you are uh, combining, or you are getting the resultant force, then you will see that the resultant force will be zero if it is in constant velocity.
Hmm.
That's why we cannot take this one. See,
Okay. Okay. Yes, sir. Another one also 11.
hello,
11.
11,
Yes, sir.
11. Yeah, yeah, nice. This one I think now you can understand.
The fourth. Sir, isn't it PNR?
Let me check. Let me check. Here we have the force on the moon due to the earth, and the force on the earth due to the moon. And what about Q? They are saying the force on the earth due to the sun, and S is the force on the moon due to the sun. So these two are not matching, right? The sun
Hmm.
once it's working with moon and the sun again is working with earth. So
Hmm.
it's not giving us action and reaction force, right? But
Hmm.
here we got moon, earth. Again, we are getting earth due to the moon. So we are getting action and reaction force, right?
Hmm.
Pair force.
So
So
yeah,
P and
B.
R, Bangladesh,
Got
right?
it. Yes.
Yeah.
Uh,
Now 12.
yes. 12.
Yeah, 12. Which one?
I think. So I think so. It's C.
Which one?
C. C.
C. P and S. The downward force of the man on the parachute, the upward force. Yes, yes. This one. This one is
Yep.
showing us pair force.
Hmm.
This one is showing us pair force. P and S.
Hmm.
So I think you understood it. So you see one thing here, uh, the same diagram like parachute one. It's uh,
Hmm.
it's uh, uh, it's depending on how you are thinking or how you are describing the condition. Okay, okay.
Hmm.
Maybe the context is same, but the way you are thinking or the way you are calculating, that's making the difference. Now
Hmm.
here the D is giving here first law, but again here for the similar context here for the parachutist we are getting third law, right? Third law pair.
Yes.
So that's why you have to think when you are getting the question how it's relating. Okay.
Hmm. Okay, sir. Yes. I think I got the concept.
Yeah, you got the concept. So this one is a nice question. Can you tell me the answer of 13? Can you read the question?
Yes. Two forces, X and Y, act on an object and produce a resultant force. The scale diagram represents the sizes and direction of forces X and Y. Okay. The Z force balances the resultant force due to X and Y and keeps
Hmm.
the object at stationary. Which row represents force Z? It's C.
Yeah. C, right?
Hmm.
This is a bit tricky question. Students get the question they circle A
Yeah,
in
yeah,
most of
AI.
the cases, but they have to check this one. Force Z balances the resultant force, right? They
Hmm.
they are not asking you what is resultant force. Rather, they are asking opposite of resultant force, right?
Hmm.
That's why. Okay, you got it. Thank you. Well done.
Hmm.
Then 14.
14 is C. It's easy.
C, largest resultant force. Okay, it's easy, right?
Hmm. Oh yeah, 15, 15. It's a bit.
15, yeah. 15 think.
In which example does friction act in the direction of motion, forward motion of the object on which friction acts in the direction of forward motion?
Yeah, this
Uh,
is an exceptional condition. Normally, what happens, the friction
friction
is
is.
always working to the opposite direction of the forward motion, right?
Hmm. Uh, so I think so. It's
Hmm?
B.
So it is also like that opposite direction. If you on a sandpaper rubbing a wooden block, it's working opposite direction.
Oh, is it A?
Yes, because the suitcase and the conveyor belt, they both are moving together, right?
Oh, yeah, 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 yeah. It's
Yeah,
got it.
that's why they both are working in the same direction. The friction and then 16. What is the answer?
A.
Very good. 17. You can answer Y, right?
Yes, it's Y.
Was the
No, sir, it's
resultant
not Y.
force.
Oh,
Yeah,
yes, it's Y.
the resultant force in the direction of Y. That is D, right?
Yeah. So
Okay. What about
20 is
which one?
C.
18.
Yes, 18 is C.
C. A short distance towards the ground, it does not reach terminal velocity. The weight of the coin increases as air resistance increases.
No, 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 I think so. No, 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 this is not this.
Which one?
Uh, I think so. Because the weight of the coin is always more than the air resistance.
Mm-hmm.
D.
Which one?
D. D.
The weight of the coin is always more than air resistance. Yes, it can be. It is.
Because
It seems
if
it
they are
is
equal,
correct.
then it will reach the terminal velocity.
Mm.
Uh,
It
so
does
this one
not.
is.
Yeah, the way the air resistance is working, uh, the weight is always more, right?
Hmm.
Okay. So the one you said C, the weight of the coin increases as air resistance increases. It's not giving enough information, right?
Hmm.
Okay. Then 19. They are talking about weight surface, right?
So I think so. It's C too.
See, so braking distance and stopping distance here. Yes, correct. Because weight surface does not uh, affect
Has no connection.
thinking
Thinking
distance,
distance.
right?
Yes.
And as the braking distance is affected by weight surface, yeah, that's why the stopping distance will also change, right?
Hmm.
So the answer is C. Clear. Done. Then 20.
It's B.
Okay, the acceleration of the new electrons is towards the central nucleus.
Hmm.
Yes, correct. So I think now you can be able to solve also the structured part, right?
Hmm.
It is. I'm sending you the cover pages now. Okay, both the cover pages. Then you send me the answer. Okay, the
Of second.
solve worksheet tonight, right? Can you send me
Yeah.
tonight? If
Both
you,
of them.
yeah, both of them.
Okay.
If you are feeling okay, then you can send me both. Then if you are done with these two tonight, then we can take the test tomorrow. Okay, on these two topics.
Yes, on Tuesday.
Yeah, next class. I mean next class.
Yes. Yes.
Okay. So get prepared. If you have still any problems or you have any corrections, then we will discuss before the test. After
Hmm.
discussing the queries or any corrections, then we
Hmm.
will start the test. Okay.
Okay, sir.
Okay. Thank you so much.
Okay, welcome, sir. No problem.
Allah Hafiz.
Allah Hafiz, sir.
Good luck.